Hello, everyone.
Hello.
Hello, hello.
April's got her friend with her.
I've got Titan, the Azure Cloud Native dog.
Yes, the Azure tiny little horse.
Yes. Amazing. Right, so thanks everyone for coming today to see this spotlight session for Robusta. Yeah, it's going to be a good one, I think. So, Rob, do you want to introduce some things, and then we can get to the code of conduct?
Yeah, so today we're talking about Robusta, which is a, let's call it it says troubleshooting automation tool. It has a lot of features going on for it. So it's going to be interesting to see that be presented in a good time fashion. And this is a spotlight session. This is where we try to highlight certain projects and certain tools of the trade and have the people who are actually behind it come and show us what's up with it. So looking forward to it.
Awesome.
Cool. Let's get the code of conduct up. Do you want to go through that, April, or do you want me to?
Sure. Thank you all for joining first and foremost. I think, just be conscious of others, be welcoming and respectful, be understanding of everyone's differences. We all have different backgrounds, technical, personal, professional, etc. Be friendly and be patient. Allow people to ask questions. We all want to, learn and grow our knowledge, and be open to all those questions and viewpoints that come around. I mean, if someone brings a challenging viewpoint, allow them to bring that. You may learn something and find a new perspective. And I think the last one sums it up. Just be kind and considerate to others. Just be nice. And welcome to the group.
Definitely. All right, let's bring in Nathan. Hello.
Hello. Thank you very much for having me here.
Thanks for coming.
So there's we got our questions coming in from all kinds of platforms here, and like we talked before we went live. We hope it's okay that we jump in and try to ask those questions during the presentation, because obviously, if we save it up until the end, we kind of forgot what the point were when we get there. So I always feel it's better to get it, as we move along. That's okay with you, Nathan, right?
Yeah, of course. And I just see in the chat that Pavan is here too. And Robert Strand, who has also joined previous streams. Pavan, actually, I just know he released recently an ebook with that's free with excellent visual guides to Kubernetes. So I just want to call that out as well. He's done some excellent work there.
Mm-hmm. His guides are so cool. The way he draws it, I don't know how he does it, but it looks so neat. It's really good.
He told me his secret, so now I draw stuff with some of the same ways as him, but it's really incredible. Like everything I do is inspired by Pavan.
Awesome. Right. So what we'll do, we'll get rid of this and we'll give you the floor, and we'll look forward to seeing it.
Thank you. Okay. So I guess I should speak first a little bit about what Robusta is. And we get some questions about that sometimes, and whether we're a troubleshooting platform or an automation platform. And the truth is that it's somewhat of a mix. And what we're trying to really do is to bring the same principles and the same approach that everyone takes when you deploy software with infrastructure as code. And we're trying to apply that same exact approach to everything that happens afterwards and how you handle alerts. And just like it used to be when I first got started and I set up servers, then I set up servers by going and like running manual commands. And today you just have a declarative file, infrastructure as code, and you put in a Git repository and use that. Then we're trying to really apply the same approach to how you handle alerts, and how you handle what happens when incidents occur, and to also turn that ultimately into code, into YAML file that sits in your Git repository. So I think what I'll do is I'll just jump in really to a demo about what Robusta is and how it works. So let me share my screen. Okay, I'm going to skip the installation. It's fairly easy to install. I'll just save time. And I'll show you an example of what you get from Robusta right after you install. So here I'm just looking at a Slack channel, and in the cluster I had a crashing pod. So when this pod crashed, then I got a notification here in Slack about that crash. And what's cool is we're attaching here the log lines that contain the full logs and full exception from that crashing pod. But this isn't some specific functionality that we built into Robusta. It's not that Robusta has a crashing pod feature. This happens to be one example of an automation that's on top of the platform. So if I go and I look at the way that this is defined within Robusta itself, then I'm just going to open up our Helm values. And the way Robusta works is that we have a whole bunch of different playbooks, and a playbook is just an automation. So every playbook has 3 parts. It has triggers, actions, and syncs. Triggers what causes this to run, and actions what you do when something occurs, and then the sync is where you send the data. So if I want to look at that example of a crashing pod, then if I go back here and I just want to understand what caused this to appear in my Slack channel, then here we have a trigger that was defined that when there's a pod crash loop, and the restart reason is crash loop backoff, we're going to run an action, and that action will generate this report, and then that will just be sent to the default destination, which is Slack. And using this paradigm, we can really model a lot of common different troubleshooting or a lot of common different observability workflows. I can say, for example, that every time that someone updates a certain deployment, I'd like to get a notification in Slack. I can say that when a Prometheus alert fires in their CPU over a certain amount, then the action will be to pull in a graph and to show me a graph of that CPU usage, or to grab a profiler result or grab some other data and send that to me in Slack, or send it to me in MS Teams, or send it to Ops Genie, or send it to some other location. So I can model all these different common kind of ways that I would handle different errors. I can model that as these automated workflows where I'm taking the knowledge that's inside my head on how I want to handle these different errors that occur and that come up, and I'm just turning that into a YAML file that then sits in the Git repository. And that YAML file in that Git repository becomes the source of truth for my team and for how we want to handle alerts and how we want to respond to that. So I'll pause for a second and see if there are any questions.
So for, how can I word this? Because the question's coming from me. So I'm an IT ops guy, and these are the kind of stuff that I would like to see, and then we can start troubleshooting it. So these YAML files, can I have like hundreds of those for different actions on the pod, or is there something from your tool which can create me a few base set ones and then I can add to it?
Yeah, so we come with a base set built in. So like if you look at that example of the crashing pod, like the pod crashed, you want to get the log. So that's a base example that we build in. And then we also bake into ourselves in the default distribution, we bundle Prometheus with us. And you can disable that if you have your own Prometheus, of course. But we bundle Prometheus with us. And then for a bunch of common Prometheus alerts, we also have all these automated actions that will run. So out of the box, the way that you can use Robusta, like we kind of see 2 use cases. There are people who say, okay, here's an automations engine. I'm going to take this and I'm going to customize it and use all these different automations. And then the other way we see people take this is they don't even care it's an automations engine. They just want like an out-of-the-box monitoring platform for Kubernetes that works well with Slack or works well with MS Teams or works well with whatever platform they're using and they want to use. And then from their perspective, they installed it. And now you had, for example, a node that ran out of disk. So they got in Slack or in a different destination a message that said this node ran out of disk, but it also had a list of like the biggest files and told you which pod was using up the disk space. So under the hood, that's modeled as a trigger, which is a Prometheus alert that says you ran out of disk, and an action that says, okay, gather data on like why you ran out of disk. But they're not even aware that that's how it's wired and built. All they know is they just got like an alert and it had the details that they wanted to see there.
That's cool. I like that.
Yeah, I'd say that like the 3 most popular ones are 1, the crashing pods, 2, out of memory killers. So when you have something that gets unkilled, then by default with the default Prometheus alerts, then you don't know why it got you don't know what got unkilled. You're essentially tracking the metric on the node itself. So you know that something got unkilled, but you don't know what. So then we enrich that and we pull in like, okay, who got unkilled and why? And then the third one that's fairly popular as if there's CPU throttling. And then we analyze and we say, okay, well, how can you fix that CPU throttling? Like, is the problem your request? Is the problem the limits? Why is there actually CPU throttling going on? And then we take, well, otherwise it's just a regular alert, but we try and turn that into something that's then really actionable.
Okay, so you sort of go through the logs and you like describe of the pods to get the events and enrich your alerting, basically. Is that it?
Yeah, maybe I'll show an example. Like, I'll show an example with the CPU throttling one.
That'd be awesome.
There are two ways, okay, or rather there are three perspectives that you can look at this. The first perspective is the perspective of someone who just installed Robusta. They're not looking under the hood. They don't care about any of it. So they either get a message in Slack, like saying like this crashing pod message, or we also have a user interface, a SaaS platform for monitoring. So I'll talk about that a little bit at the end. But you could go in here as well, and you could see the same data here. So you open this up, and here you see something. I didn't set up the example with the CPU throttling in advance, so I'm just showing here an example with the crashing pod. But they would see here the data, and they would say, okay, it's crashing, or okay, there's CPU throttling high, and here's the reason why. So that's the perspective of the first user who doesn't understand anything about the internals. They're just experiencing this because they're getting the data. The second perspective then is the perspective of someone who's configuring Robusta with YAML. And from that perspective, like you go in here, you look at the values file. This is all our Helm values, so it's defined that way. So if I look here for like CPU throttling high, then I can see here this part of the file. There's a trigger whenever there's a Prometheus alert, and that alert's name is CPU throttling high. Then you're going to run two actions. The first action is called CPU throttling analysis enricher. That's an action that's specifically targeted at this one alert. It's one of the more specific actions we have, and it will tell you why there's CPU throttling. The second action here is a general action. It says alert graph enricher. So this will just pull in a graph. We'll take whatever pod that this CPU throttling high was occurring on, and we know that because the data that passes from a trigger to an action is typed. So if this alert fired on a pod, then we know which pod it fired on, and then these actions run in the context of that pod. So here, this action, alert graph enricher, says, okay, go fetch a graph of CPU and do it for a pod, and then it will take the input from the alert. So when you're using this, then as like someone who's configuring in YAML, then now you get this data and you can customize and you can play with it. And of course, the question is, okay, well, how do you know that you can type here CPU throttling analysis enricher? How do you know what the parameters are here? And I can type resource type or item type or whatever. So of course, you just go to the docs, or you read the source code, but the docs are easier. Yes. So I can go in, I can go in here and I can like look at all the actions. And we had something funny happen recently. I'll show the docs in full in a second. But we had something funny happen recently where we need to get a stack dump. We had someone running Robusta, and we always use Robusta to debug Robusta as well, and they had some issue with Robusta. So we said, okay, we should add a stack dump action so that there will be an action that you can just run that will like gather a stack dump from a Python application. And we have different advanced troubleshooting capabilities, so it's fairly easy to do that. And we didn't have anything in the docs about that. And then one of our developers started developing that, and he looked over the source code for similar actions we have for Python profiling and for Python like memory analysis. And he said, wait a minute, like I was looking at the code, we already have that action. Someone had forgotten to put it in the docs. So documenting this stuff is important.
So we have the docs, we have the code and everything we can look at to do this. Do you have any plans to like create something for Visual Studio Code to sort of help create these YAML files, sort of like an extension for VS Code?
Yeah, so what we really want to do is we want to create something. We need something called Robusta, like Zapier for DevOps, or if this then that for DevOps. We really want to have a visual editor where you won't have to go to the docs and then look in the docs and see, okay, there's this action available and this trigger available, and I can write this YAML. You would just have something that's drag and drop where like you have a drop down menu and you choose it from there. We thought that would be one of the first things that we would do when we launched Robusta. And then something that like always happens, which is a good thing to happen, but people come and they ask you for other stuff and you're like, oh, why do you even want that? But the user is always right. So
Mhm.
when people are asking you for one thing and you think they want something else, or something else was a more interesting feature, but no one turns out to want that, and everyone wants a different feature. So we had to adjust our priorities a little bit, but we do think that is something interesting to add on, to have this visual approach to it.
Awesome. Sounds good.
Yeah, so I'll show an example here in the docs. Let me just show an example of this. So if I go, for example, into, let's say, event enrichment, and I'm just going to pull up one of these, the other graph enricher. Even looking on the wrong page. Let me search here. Yeah, event enrichment. Oh, it's yeah, I know I did other graph. Okay, so here's an example. This one is for a custom graph. We can pull in any graph you want. And I think here for the other graph enricher, we don't have a screenshot in the docs, but I can see here like the full an example configuration of how you would configure this. I can see which triggers this specific action supports. So this only supports doing it on a Prometheus event, on a Prometheus alert, that is. I can see each of the parameters that it takes. So we have a whole lot of different stuff here. So you can like run PS, you can run any bash command on a specific node in a specific pod. Of course, it could be the specific pod that an alert fired on, the specific node that an alert fired on. You can fetch the logs. So we have all these different things here. And there are a whole bunch of them. And like I said, we probably do need that user interface because it does get hard sometimes to really track each of these actions and what we have available. But we have a whole lot of actions. But the next thing I want to show is under the hood, what are these actions really? Like, let's say you want to do something that's not here for one of these actions. Recently, someone said when a certain alert fires, I want to kill a pod. And we don't have yet built in a delete pod action. So how would you go about implementing something like that yourself? So the first hack that you could always do is you could just do something like a bash command. And you could do something here where you're configuring an action. You're taking the generic action that runs a bash command, and then you can do it that way. But I'll show you the real way to do it. That takes a little more time, but it's also fairly easy. So the secret is that every single one of these actions is just a Python function. And let me show you what that looks like. So if I go here, I'm going to define a new action, and I just put on this decorator action. And let me think. Do you have an idea for an action maybe that we want to implement? I'll show you how to get logs, let's say. That could be good. We already have this, but I'll do it from scratch. So I'm going to write a Python action, and we'll call this logs, get logs. Now, if I was using this in YAML, by the way, then I would just put in here under the actions, just put in here get logs. That's how it works. So going back to this action now, I'm just writing here an action called get logs. And we can decide here what type of input our action should take. Should our action take input from something that occurs to a pod? Should it take input from something that occurs to a deployment? We choose, and then according to what we choose, it'll be able to be triggered in different circumstances. So we'll choose that this action can be triggered on anything that has a pod associated with it. So if a pod is updated, if an alert fires on a pod, if a pod had started crashing, anything that occurs that's related to a pod, we'll be able to use this action with. And so I just define here, I'm taking a parameter to this Python function that's a pod event. And right from here, I can now say pod.object, event.getPod. And I can access here all the different YAML fields. So here we have every single field that appears in that pod's YAML. I can access here in code. So I could just print here the name. I could go and I could fetch the logs. I'll say event.getPod. We have an API here, so I can get the logs. So here that would be the logs. And now I could say, let's run a command on this. So ps output the event.getPod.exec. And we're just run ps. And then we make it very easy to send stuff to Slack as well, to send stuff to MS Teams. You can send it wherever you want. We're agnostic to that. So you just write here event.add enrichment. We're adding data that we enriched about this event that occurred. And I just put here something like a markdown block or a file block, and I'll give it the output. And that's all there is to it. And then based on what the person configures in YAML, then this log or the output of PS or wherever you wrote here would arrive either in Slack or Telegram or MS Teams or Ops Genie, wherever you define in the YAML file.
Awesome. So with that, some of our pods, you've got your init pods and your sidecar containers and stuff like that. Can that get the logs? So if I have a multi-container pod, can this get the logs for each of the containers individually for us, or how does that work?
So let me check the source code. I don't remember exactly what's in there, but let's see. Like if I go back here, then we're just calling a Python function. So I can check what our API is actually doing. And it looks here that either you have to specify a container.
Mm-hmm.
So either we specify a container or we take it from the first container.
Okay, cool. So it can get them if we just do a bit of enrichment of the code, and we can then get the sidecar container logs or the main ones. That's cool.
Yeah.
I like it.
And then we have like concepts of more advanced triggers. So like I'll speak now a little bit. We spoke a lot about the action side. So if I go now and I speak a little bit about the triggering side, then for the triggers, let me go down over here. So we can trigger based on stuff that happens in Prometheus alert, stuff from Alert Manager. We can trigger based on stuff that occurs from the API server. This is the number one interesting one. There are smart triggers, which I'll speak about at the end. We can do scheduled triggers. So you can say, run this action like every 10 hours. So maybe an example of an action like that is there's a backup action that just creates using the newer APIs with persistent volume snapshots. It just goes and creates a persistent volume snapshot with a certain name. So that you could put on the schedule. Say I want to get a persistent volume snapshot of this specific volume every 10 hours. And that would just go ahead and do it. So that's for scheduled triggers. Then there are manual triggers. That's if you say, okay, I want to run this action right now on this pod, on this node, on this object. Webhooks is so you can trigger it yourself from an API. And then you can trigger it from like logs and Elasticsearch as well and other stuff. So the interesting one here, the most interesting, is Kubernetes API server. And we can wire up here. So like anytime a deployment is updated, anytime a pod is created, and we can essentially wire up to any change in Kubernetes itself. We can cause an action to then run. So the number one use case for this is something that's like a little bit that isn't quite troubleshooting a specific action, but it really comes into it very well. Let's say, the analogy that I like to give is, let's say you plug an electric device into the power, and then the lights in your entire house go out. You're probably going to suspect that electric device that you just plugged in, right? So when an alert fires in your cluster, you very often want to know what happened 1 minute right before you went and like that alert fired. What happened that maybe preceded that caused the alert to fire? So if we have all this entire framework in place and we can track events now, then like the cases around tracking and correlating changes and errors, they now become very trivial. And one of the things that we like about Robusta that makes it very useful for us is you can take all these very different use cases and they end up like the framework, the concept here of triggers that occur in your cluster and then actions that you run and then sinks and destinations that you send it to. Those end up being like a very powerful way that you can use to model all these different use cases. So one use case here is I want to take all the different stuff that occurs in my cluster and I want to correlate that with my alerts, or I want to track everything that happens and I want to audit changes to my cluster. So I'll show a few examples of that now. So the first example I'll show will just be in our SaaS platform. So let me share my screen again. Now, our SaaS platform here, it's just a copy. It's just another destination. Just like you send stuff to Slack, or you send stuff to MS Teams, then you can send it to this user interface as well. And we also have an on-prem version of this. Sorry, I've been told I shouldn't say on-prem anymore. I think the term is now self-hosted. We have a self-hosted version of this in closed beta now. So if I go here, I'm just going to go here to global timeline, and here I can see everything that's happening. And here I can now track all the different changes. So I'm going to just zoom in over here, and I'm going to look at a specific change that someone made in my cluster. I think it was actually created over here. So because it was created over here, I'm not seeing the full diff. So in this case, a resource was deleted. So I'll probably have to try a little harder, maybe go back in time if I want to find.
That's quite cool that you can see the green for the newly created, the red for the deleted stuff, and you can see the whole YAML file of what it was. So if I needed to recover quickly and they've cleared up source control, I could just get that, chuck it in my source control, and get Ops to do its actions, and I'll be back up and running. So that's quite cool to see that you're tracking that kind of stuff.
Yeah. And again, the interesting thing turns out to be that like you're looking at this, and you can look at this now in terms of multiple user stories or multiple use cases on top of this technology, on top of this concept. There's a trigger that something changed, and I want to just send that data to a different location. So an example of that, to take the GitOps example, like you can say, okay, well, why don't you track all these changes? And whenever there's a change, I'll just write it out to Git repository. So it's almost like reverse GitOps, right? Like you're writing out the changes to Git repository, and then you're just tracking what actually happens in Git. And of course, you have your GitOps repository, but you also have an audit repository that you can go to, and you can see if someone like took an ad hoc action or did something like that. So we actually just have another.
Does this tell you which user made the change as well, or does it just say a change happened on the cluster?
Okay, so let me show you. I'll just pull it up over here under the actions. We have this here just as another set of actions for change tracking. And this action is the Git change audit. So here we're writing stuff out to the repository, and you can see what changed and when it changed and so on. And because we're taking this from the API server, then the API server doesn't actually store metadata about who changed it. But one thing that's on our roadmap is to add on here the Kubernetes audit API, just as another source of events that can generate these triggers and that can cause actions to run. And then we would get the same data, but now we would also know who changed it, and we could easily audit that as well.
That's awesome. Yeah, I like that.
It's like if you think in general about paradigms for how you do observability and how you do monitoring, then there's one paradigm that's like really a good, very powerful paradigm that's proved to be useful, which is that everything is a time series, and then you're just writing out queries like in PromQL or something else about time series data and alerting. And that's a really useful and good paradigm. But what we're starting to see is that when you're running these complex environments, then time series aren't always sufficient. Like if you have a pod that's been CPU throttled, then just by looking at a time series, it's very hard to tell why it was actually CPU throttled. Like in the old world, you had a pod that was running on one server, you had an application that was running on one server, and if it got CPU throttled, you had to put it on a bigger server. But now it could be because of all these other factors. Something else running on the same node, because you defined the limits wrong, because you defined the request wrong. So actually, you need something that's more powerful than time series. You need a decision tree. So what we're doing, I see there was a question also in the chat. Can you add logic to the alerts? So the answer is absolutely yes. Like the alert is still being triggered by Prometheus, by Elasticsearch, by this external system that's either doing it based on like Elasticsearch monitors and some regex. We're doing it in Prometheus based on time series. But then there's this extra step that we're putting in between, which has this logic that says, okay, why is this occurring? And I always like to compare that to also how you do deployments, right? That you do deployments with infrastructure as code. You're not doing it ad hoc. So why not handle alerting and respond to alerts with a similar principle where it's code that's kind of embedding this for you, what your best practice actually is.
Yeah, no, it definitely makes sense. Because like if you think about like Grafana alerting, it's all time series and everything. So like this, I love the way you're enriching the logs and the alerts with everything you need to easily go and troubleshoot that issue and fix that issue just from looking at Slack or looking at Teams. So that's really cool. I like that a lot. So with the platform, you've got your SaaS offering. Can I have many clusters talking to that one SaaS offering and then have that overarching sort of monitoring plane?
Just earlier today, someone asked me if they can connect 50 of them. So the answer is absolutely yes. Like, it's a multi-cluster world. We built Robusta for a multi-cluster world with multi-cluster in mind from day one. Very few people are just running on one cluster anymore.
Yeah, seeing that a lot. You got your dev cluster, your test cluster, your production 1, 2, different region production. So yeah, that's cool that I can do that. I'm liking that.
Well, let me show that to you. Let me take a look. I'll show you. I think on this account I have. Let's see why I have connected here. I'm just going to jump over to the node screen. So essentially, I'll say another word here. Essentially, we're getting here in the SaaS platform, we're getting all this data that's just coming from these triggers and actions. And the cool thing is we can also gather data on demand. This is something that we'll be rolling out very soon. Like I'll be able to go and I'll look at a specific pod, and maybe now I want to drill down. I want to actually see the details like about this pod, or I want to fetch data, or if it's like Kafka, then I want to actually connect to that pod and grab some extra telemetry. And the traditional approach to alerting and monitoring is that you gather all the data all the time. And that's really expensive. And then you have all this data and it's uncorrelated. And then when an alert happens, you have to go and you have to start digging. But we're taking a different approach here, where because we can gather this data on demand, then like I'll be able to open this up and I'll just click on something and it will fetch for me the exact data that I need, which is just from one of these automated Python functions, from one of these Robusta actions. And it will be able to get that for me exactly when I need it at the exact right moment. And I can fetch that data in advance right when the alert occurs. So I can say, like, next time there's high CPU, go and run a CPU profiler at that exact moment. When there's high memory, or 10 minutes before I'm about to trigger like an kill, go and fetch for me a memory profile, and then compare that 5 minutes later so I can know what's leaking memory. So you can do all sorts of advanced triggering logic like that. But getting back to the original topic, so if I'm looking at the SaaS platform, we're running all these different actions here. And sometimes I'll switch screens, and this will behind the scenes be running some actions to get some additional data. So I can see here, if I'm looking now at the nodes, and I can see here I actually have on here, I have a GKE cluster, I have a Civil cluster, of course I have my Azure cluster that I'm doing this demo on. And I guess if we're already looking at this, I would say Azure is the most cost effective in terms of CPU. Like if I look here, one of the things that we're showing here is for each node, we're showing the CPU usage, but we're showing it with 3 different metrics. So I'll look at the GKE example. So I can see here the red is allocated. So that's what has been handed out by this node. That's what the scheduler has assigned. Green is available. And then the gray here is system reserved. So that's the CPU that Kubernetes is reserving for the node itself, that is not available to any of the workloads. So if I look here actually at GCP, then I can see that 53% of the capacity of this node on GCP is actually unavailable for my workloads to run on. So if I took a 4 vCPU node, only 2 of those vCPUs are actually available for me. And if I look at Azure, Azure is by far the winner on this. So Azure is actually taking a system reserved of only 5%, which is much, much smaller.
Yeah, so you definitely get more bang for your buck when you're allocating resources based off CPU. That's cool.
Yeah. Because everyone says you have 4 vCPUs and this is the type of CPU and this is that. When you actually look into it, very often you're comparing apples and oranges, because the node might have a certain amount of CPU, but a large part of that CPU is often reserved for Kubernetes itself. So you're not actually getting that CPU.
Mm-hmm.
An area, yeah. An area that we want to focus on in general, again, like if we look at these actions and what we can do with them, then like people want to know, okay, like tell me about the resource usage of this deployment. So that's just another action that outputs a graph, or that's just another action that can take kind of this operational knowledge about what you would do as a person, as a human, what you would go and analyze, and we're taking that operational knowledge and we're turning that into code, and that's really the core philosophy of Robusta.
Yeah, definitely. And so it's open source, is that correct? So anyone could come and help contribute some stuff to it and make it better, or
yeah, absolutely. Nice. The SaaS platform is, at least for now, closed source, and that's what we use to sponsor the development of the rest of Robusta. But everything other than that is open source, and the SaaS platform, I have to say, is also an optional add-on. So if you don't want to use that, then you don't need to. And if you want to use that self-hosted, we also have options coming for that soon.
Cool. And like with the self-hosted, you can get the similar features as a SaaS one, but you're just paying for the compute cost and the storage costs and stuff like that.
Yeah,
that's really cool. Yeah, that's definitely. Just thinking how I could start using this at work now.
Yeah.
So yeah, I like this a lot. Yeah, because it just seems very nice that you're enriching these logs and these messages with so much information, just by using some Python scripts, and you can get the right information at the right time as well, which is really cool.
Yeah. One thing that we saw when we started building this is like we went to a few different large enterprises and we said, okay, like we're building this solution for gathering data automatically when like alerts fire. And then we heard from one very, very large enterprise that said, oh, we already built that in the house. And for us, actually, that was a very positive thing to hear because it also validates the need for this. But we've seen some of the challenges of building it in-house is then you end up like creating these same components like again and again in-house. And we thought like, okay, well, everyone who has a crashing pod, they all want to see the logs. So like, why not write one action, write it well, write it once, and just let people configure in YAML. So that's the philosophy.
Nice. Yeah, I like this. I like it a lot. So what else can the platform do for us? Anything else you can show us?
Yeah. So maybe the next thing that I'll show will be a very different example of a troubleshooting action. So I'll go back to the use case that maybe my application has high CPU, but the action now, I don't want to take an action that's like a Kubernetes specific action. The action that I want to do is actually really related to my application. So if I have a Java application, for example, I want to get a stack dump from Java. If I want to run JMap or JStack, if I have a Python application, maybe I want to run CPU profiler. So I'll just give an example of that. So in this case, the action that we're going to trigger will be one of the Python troubleshooting actions. And I'll just take an example from the docs. And I'm just here in the Azure console. And okay, so what I'm going to do is I'm going to run this command, Robusta playbooks. That's just our CLI. Playbooks trigger. I'm going to trigger an action. I'm going to trigger it right now at this exact moment. And I'm going to trigger an action that's called Python profiler. So this will go and it will Python the profile application running inside the cluster. And I just have to give it the name of the pod that I will give it as input. I have to tell it what namespace that's in. So I'm just going to copy that. kubectl, I'll get pods again. I'll give it Robusta itself, which is a Python application. So this will go and this will trigger it. And if I go over here to see the parameters, here we're running it. I think the default is for 2 seconds. So we're running this profiler for 2 seconds. And I can say only profile a specific pod or, a specific process. I just left everything with the defaults. So if I go over here back to Slack, then I should have just gotten the result. I think my sound is off, but I just got a result here with the Python profile. And I can open this up and I can see exactly what that Python application was doing at that exact moment in time.
Wow. And so the CLI can be installed on like Windows, Bash, Linux, any shell. And then from that, that CLI just sort of execs into the pod and then gets the information we need and then turns it off? Or
so it's a...
Oh, I think we've just lost him. He should hopefully be back shortly. I think he's just, instead of stop sharing the screen, he just kicked himself out.
That might be.
It's a good point.
Yeah.
Here he comes back.
Hi, sorry about that. I meant to...
No problem.
The buttons look so similar, so I can understand that. Cool.
Okay.
So
Yeah, we're live again, right?
yes, we're live. Yep.
Sorry, guys, about that. Yeah. So, just repeat the question.
So the CLI, when you're doing this command line, it at that point to get the dump, it's going in. It's execing into the pod, doing what it needs to do, and then sending it off to Slack or Microsoft Teams or something like that. Yeah.
Yeah. So that's for most actions you can do it that way. Specifically for profiling, then it's a little more complex because the Python application that you're trying to profile, it might not have a profiler binary inside that pod. So in Kubernetes, there's this concept of ephemeral containers, which is something that you go and attach a container on the fly to an already running workload, to an already running pod, and then you attach a container just for debug purposes, gather some data, and then your container disappears. So ephemeral containers are the correct way to do it. They're only available, though, in very, very recent versions of Kubernetes. So
1.23 plus, I think, isn't it, or something like that, if I remember right?
Yeah. When we got started, 1.23, I think, wasn't even out yet. So I guess now it's not that old of a version with the rate that they move at. So that new version, sorry. But we implemented something internally that it simulates ephemeral containers for platforms that don't support it as well. So we put a new pod running on the same node, and then you can run different debug actions that way. But from the perspective, again, of someone who's writing like one of these playbooks, there's just an API for that. So you just run this command, which is coming from this other container, and run it on the process. And it's really easy to add on these actions yourself.
Nice. So because it's doing all this extra cool, fancy enrichment, I'm guessing the Helm installation needs some super high privileges, maybe cluster admin. Is that the case, or does it have different kind of rules in the cluster?
So it's just up to you. It really depends on what type of actions you want to take. So we're actually not taking cluster admin or anything super high by default. What we're taking is security though. And then what we're doing though, like when you run that profiling action, then what we would take there is we would create something that has host PID permissions and has, I think it's syscap ptrace. And then that's sufficient specifically for the profiling use case. But it's all up to you in terms of what actions you want to run. So you can say, I don't want to do this, or I want to restrict that more. And then we have features planned as well around really more fine-grained permissions. We're saying, okay, only certain users are allowed to do certain actions. And then the thing that we sometimes hear from security people is, oh, this is wonderful, because now I can take away everyone's like manual access. So like, okay, you want to profile something or you have to do these troubleshooting actions. Okay, we'll give you those actions, but you can never access the cluster like manually yourself. You will never be able to access it anymore because you no longer need to. So we also see that sometimes.
Yeah, that's definitely a good tick in the security box right there. No access to the cluster from an end user perspective.
Take access away from everyone. Yeah.
Yeah, that's cool. So we've got this app, we've got the nice dashboards and everything. We can install it on any cluster, and we can connect all of these clusters up to this one nice SaaS application and get everything we need off there. What do you have in the roadmap coming up that's going to make the product even better?
So Victor Farsick says we need to support CRDs. And when Victor says something, it's generally a good idea to listen. The video about us yesterday, excellent video. So CRDs is one big thing on there. So we want to be able to track all changes to CRDs, to make it easier to write these custom actions around CRDs. That's one big thing that's on the roadmap. And then another big thing that's on the roadmap is also focusing around like the out-of-the-box experience for people who just want a monitoring system. And they don't necessarily care as much about how it's working under the hood, but they just want a monitoring system. They want to be able to open up that one dashboard, see all their clusters, be able to compare different stuff that's occurring in different clusters. For example, sometimes we hear from people like, I want to see when one application is running on 5 different clusters or 50 different clusters, where's their drift or where's their one version versus another version. So a lot of different day 2 operations, and a lot of them are based around monitoring and alerting and responding. And so we have a whole bunch of features planned there, but not just. Essentially what we're trying to do is we're trying to build out like all the stuff you need for day 2 operations to make it automatic. That's the broader vision. So we're starting with alerting and trying to provide really the best alerting dashboard for Kubernetes. The default alert manager is very good at kind of doing grouping and doing stuff like that. But if you want to see all the alerts that happen, you want to see that in the timeline, and when something started firing, when it stopped firing, how it correlates with changes that occurred in the cluster, and that can be difficult to do. So we're trying to provide really the best alerting solution for Kubernetes with multi-cluster support. And then we're trying to also build out these other day two operations.
Yeah, that sounds good. Day two operations are always a pain for so many people. Day two sometimes turns into day 3, day 4, day 5. It just goes forever on and on with Kubernetes now in this giant ecosystem we've got. So that's good. Anything else you can show us of what the tool can do?
Let me just share my screen again. And I'll try not to accidentally disconnect this time. So if I'll start off by walking through maybe the SaaS platform a little bit more, which I haven't done so far. So if I'm here looking at the SaaS platform, then I can see here, so all the different workloads that are running in my cluster. Again, it's a multi-cluster world, so I can filter here, see stuff only running in a specific cluster. I can see stuff that was just updated in the last X amount of time. So here's the pod that was updated recently. And then if I click on something, I can see here all the different events that are occurring on this pod, so on this workload, in this case, a deployment, across all the clusters in which it's running. And I can see here we had a pod that something was crashing, and I can open up the different details, and I'll be able to see the logs here, see what was crashing and why. So all the data that's coming from the system then shows up in here, as well as the data from Prometheus and your other systems that you can forward to here. I can see that in the global timeline. I can look at the different nodes. Very soon, we're going to have some more advanced troubleshooting capabilities. We're going to take some of all the different stuff that appears here in the documentation for all these different enrichment actions, and then make those available on the click of a button in the UI. And then one other thing I also want to elaborate on a little bit more, aside from the alerting stuff, also more on the troubleshooting side, is we spoke about Python profiling and Python memory dumps and stuff, but there's also something else you can do, which is to really attach a debugger to something running inside your cluster. So that's really useful to do as well. So I didn't prepare a demo, but I can try and do this. Let's try and do it ad hoc. I won't be able to do it because I'm running it here from the web console, so I don't know how to port forward from here.
Yeah, that makes sense. Okay, so does it support Windows containers as well? Because I'm starting to see a lot more companies going live with Kubernetes, but basically just packaging up their app into a container and running it on Windows, so they can get some benefits of Kubernetes, and then work on containerizing it for Linux and that to get all the benefits. So can this tool help people in that sort of instance on their journey to full container?
Long term, yes. That's another thing, though, that's on the roadmap. But today, we don't have support yet for Windows containers.
Cool. That's good, because I can see quite a lot of IIS apps running, and having this tool be able to pull the IIS logs off and get all the stack traces of that, and it could be very handy.
We might support it. It's one of those things that you discover sometimes where you end up supporting stuff that you never knew you supported.
Somewhere in the code base again.
No, because I'm not sure if you have to actively do something to support Windows containers, or if you have to actively do something to not support Windows containers. Like if I did kubectl exec, would that just work on a Windows container?
Yep. Yes, and then I guess, can you run PowerShell inside? Because you can say you can run Bash. Can you run PowerShell as well? Because if you can, then you could probably do everything.
So we're just running kubectl exec, like the API equivalent of it. So like I wouldn't be entirely surprised if it just worked, but I haven't. I've never tried that before.
Might have to have a try myself, see if I can get this work. So that could be a cool little blog post. Yeah.
Maybe I can actually show. I think I do have another test cluster. I was just thinking about the example with the debugger. I might actually be able to show that in another test cluster I have set up. Then I can also show how it integrates with VS Code, which is cool. So let me see about that. I'm just going to open up Visual Studio Code in the meantime.
Cool. Yeah, because I'm just guessing, if you are literally just doing kubectl exec, then as long as a pod has PowerShell installed on it, which it should do because it's Windows, you can just cat out the IIS logs. So yeah, it should work.
Let's check our source code. The source code never dies. So
Yeah.
let me see. Okay, so I'm going to go here. I'm going to go under the actions to event enrichment. I just want to check what the name of the action is. So we have here like pod bash enricher. So I'm just going to look at the example config. Okay, so the action here is called pod bash enricher. And because I have poor memory, I'm just going to search our own GitHub repository to see where that's located. Okay, so what we're doing here is we're calling just pod.exec. Oh, it's not auto-completing for me properly. So I'll open that up in PyCharm. Okay, so we're doing exec. Either you specify a container or we take the default container. And we just run here another function. So first we wait to make sure that we're not trying to run this command too early before the pod is actually running. And then, yeah, we just do connect get names. Yeah, we just do an exec under the hood. So this might work. You'll have to let me know, and if it doesn't work, then we'll have to fix it. But I suspect, based on what I just saw in our code, I suspect that would just work.
Awesome. Yeah, I'll definitely give it a go this week or this weekend, and I'll let you know, because that could save me quite a lot of troubleshooting on some of my IIS containers.
Yeah. Okay, let me do an example here with VS Code. There's always this fear when I do live demos, but that I haven't prepared properly, that like somehow it's now broken, but we'll hopefully be okay.
They're the best kind of demos in my eyes.
Okay, so I have here just a simple Python application. We'll remove that. And it basically just does an infinite loop. And if I go over here, I'll make that bigger. I'm killing an older version of the pod because like God knows why I've done that in the past during previous demos. So I figure it's best if I delete it and take a clean one. I'm just going to get. Yeah, okay, so here I have a running pod Python debug me. That's just an instance of this application. And I want to emphasize, just like with the Python profiler, I did 0 setup on this. So that's the nice thing. You don't have to set anything up in advance. But like often if you want to debug stuff, like if you want to debug stuff in your cluster, if you want to profile it, then you have to have like remembered yesterday to set it up in advance and enable a profiler. So all this is 100% dynamic. Like we're taking advantage of the power Kubernetes gives us, and that there's this one unified control plane. So I didn't set anything up in advance. So that's nice. Now I'm just going to jump over to the documentation again. And what I want to do is here, I want to run one of the Python troubleshooting actions. And I want to run here Robusta playbooks trigger. And this time, instead of putting in here like a Python profiler, I'm going to write Python debugger. So we'll just do Robusta playbooks trigger Python debugger. Name equals, we'll bring the pod name, and namespace is default. Now, if everything goes well, then behind the scenes, what's happening now is that we're putting another pod running on that same exact node. And that other pod is now going to set up the VS Code debugger. We're just taking the standard VS Code debugger, and we're going to attach that to an already running process. essentially what we're doing is exactly what happens like if you do attach to process from VS Code. We're just doing it on the node for you. And like everything we do here, like if you know how to do it, it's not hard to do. But oftentimes people will say like, oh, how on earth can you debug like a Python application running on Kubernetes? It's really not hard. It's just another example where it's easy to do, but you have to do all these manual steps. So by automating it, we're taking like the knowledge that was limited to a few people who bothered to learn how to do it, and we're now making it way more accessible. So I get here a message done, see instructions for connecting to the debugger in Stack or Robusta UI. So the output just gets sent to wherever you're sending your output to from Robusta. And I'll go back over here. I should have a new message here. Let's see what I did wrong.
Is it because it's a different cluster, so it'll be a different Slack channel?
Oh yeah, that's right. Good point. This is like private. That's private channel, I think. Yeah, okay. Thank you very much. Nice catch. So I'm just going here, and now at this point the debugger is listening. Now at this point I have to do something that, like, from the perspective of someone who's designing Robusta, is a very, very extremely hard challenge, more so than like attaching a debugger. We have to deal with a security issue, which is how do I securely essentially take my computer and connect it now to debugger that's listening in the cluster. And the solution that we took is we don't do it. We just tell you run port forward. So we make it your problem instead of our problem. So run port forward. So I'll run here port forward, and then now port forwarding to the debugger that is listening inside the cluster. Now all I have to do is I have to go over to VS Code. I can just attach to that Python application. So I'll do start debugging, remote attach. And just like that, if this works properly, yep, I can see the output now from this application. And I'm going to use a cool VS Code feature called non-stopping breakpoints. Sorry, they call it log points. And when we get here, we'll just print this isn't stopping the application. And let's print the time module. Time dot is it time now? I don't know. See if that works. Oh, yep. And here I'm printing that, and I'm printing the current time.
Oh, that's really cool.
Yeah.
That's made it super easy with the nice instructions in the Slack channel as well. Anyone can just debug it. Yeah, that's really clever.
So I'd like to end actually with a question for you, because I've shown off a lot of different stuff now, right? And like some things I got asked, okay, so is Robusta a troubleshooting platform? Is it an automation platform? Is it an all-in-one monitoring stack? So I'd like to hand that over to you now, actually, as someone who's seen a lot of different capabilities. And I'd love to hear your input on what it is that we're building, because we definitely see a lot of different use cases.
Yeah.
For them today.
So for me, it's kind of like, I wouldn't say a full silver bullet to fix your monitoring solution, but it's definitely a tool I'm going to go look at further, because I think there's quite a good use case to make debugging easier, management of and monitoring of multiple clusters and troubleshooting the clusters. Because like at the moment you have your Grafana dashboards, which only do sort of time series properly, alerting and stuff, whereas this, and it only gives you what you want in your queries, whereas this has a lot of the out of the box stuff already done for me. And so being an IT ops person, my background has always been least, like anything IT ops is least admin effort, and this tool ticks that box for me. So I like it a lot. What would be good as well is to maybe have some best practices put into your stuff as well. So if you notice a misconfiguration or something, say, oh, a best practice would be to do this instead. But yeah, I can see this working quite well, especially because the multi-cluster support as well, and your central point of tooling, and then your way you can push the alerts off to different systems. So like an API endpoint, and then from there I can do whatever I need with it. Help desk tickets or pages, calling people, text messages, emails. So yeah, it's quite I would call it an integration piece.
Yeah,
that's what I think I would call it.
Yeah, I think one we heard it described as alerting orchestration. And I think that's actually a really good description.
Yeah. Rob, what do you think?
I think you're kind of getting to something at least now. So like some sort of like integration engine, integration tool. There's a lot of things going on here that you can do and customize, which obviously the customization is what I like the best, because one size doesn't fit all. But you have things like Python profiling and the Java related things. Can we extend that? Can I like write something for Go, for instance, and then like just shove it in here and then have that trigger?
Yeah, it's probably like 3 lines for Go. Because essentially all we're doing, like in the Python profiler, we're just like, none of this we invented ourselves. It's like we're just doing the orchestration for it for profiling. We're just taking PySpy. If you do it for Go, you just take pprof. So all you want to say is like, take the pod that I got as input, check what node that's on. It's like 1 line of Python, and now schedule another pod on that node in the root PID namespace or using an ephemeral container, and just run the container there that has pprof and give it the right process. So all that is like, we're doing it for Python with PySpy, or we're doing the same thing for VS Code to run the debugger. All that you're doing is you're changing, like in the command that you run, you're changing the word PySpy with pprof, and you're changing the name of a container from a container that has pprof in it, that has PySpy in it, to a container that has pprof in it.
Yeah. Yeah, so as long as we kind of, I didn't see that in the documentation. Obviously, it's not really that hard if you start like diving into the code, but having that kind of like being, I guess, pointed in the right direction at least, would be cool, because it makes sense. It's not a whole lot going on in itself. It's just it's like I said, it's like the integration engine. Stuff is ready there for you to use. Which means obviously you can customize it a whole lot, which I like. So yeah, it's a cool tool. I like it. I'm gonna look more into it as soon as I have the chance.
Yeah, sure. I'm looking forward to the PR that has support for pprof.
Well, I keep on saying that I'll sure I can do that, but I keep on saying that to everyone, which doesn't work. So we'll see. Maybe if I get stuck in like the weekend doing this, all of a sudden you'll get a PR.
What'll happen next time? Tell you what, next time that you have to do something with pprof manually, and you have to like then set it up, or like start figuring out what PID to run it on, you're like trying to orchestrate it or run it at the right time, then that will be the golden spot where like by doing it, you save yourself time as well.
Yeah, that makes sense. I'll try to do that.
Okay, fair enough. And
let's see if someone else did before me.
Yeah.
Awesome. Right, so I think we come up to just over the hour mark now. So thank you very much for the conversation, the demos, and everything today. It's been awesome to see more about the product and what it can do and where it's going. So I'm excited to start using it and looking into it further, and going to test out the Windows container login and stuff. So cheers.
Thank you. I had a pleasure. It was fun for me to also set it up on Azure, and it was a pleasure to do as well. So thank you.
All right. Well, thanks a lot, Natan.
Thank you. So everyone, thanks for watching, and we'll see you next time. See ya.
Cheers.